Okay, good morning. So let us continue the lesson today. So we started to talk about fractional powers, fractional exponents last time. Okay. Hello. Okay. So we started to talk about the fractional powers a little bit. So I didn't write these things down, so it might be good if you have them somewhere in your notebook. And then this is a terminology that is very, very ubiquitous in mathematics. Theorem is a statement that needs an argument to show its validity. So when we say a theorem, it means that there is a claim in that sentence, in that statement, that needs to be addressed. I have to have a good argument to say why this statement is a true statement. Okay? So whenever you see a theorem, automatically what is coming after that is called a proof. Okay? But here, this is more advanced, even though it seems very simple, but if you want to really show it abstractly and rigorously, then you need a little bit more advanced mathematics, which is beyond the scope of the high school studies. Okay? So here you have to trust me on this. But after that, in principle, you should be able to deduct logically everything from this definition. Okay, so here this theorem is claiming something like this. It's telling you that let A be a real number. So I have underlined this A, so don't get confused with this English article A. So this A is a number, so let A be a real number and let n be a natural number. We have two different cases. The natural number can be an odd number or can be an even number. So depending on the situation, if n is even or odd, we have two different scenarios, yes? If n is even and if a is non-negative. By the way, when I say non-negative, it is different from saying positive. 0 is neither positive nor negative. Okay? So when I say non-negative, it means that greater than 0 or equal to 0. But when I say positive, when I say A is positive, I mean A is strictly, this symbol is read A is positive, but this symbol is read A is non-negative. Okay? So then there exists a unique positive real number whose nth power is equal to A. So the existence here and the uniqueness is the claim in this theorem. So there exists a unique positive real number whose nth power is equal to A. Okay? So you need to trust me on that. The existence is true. Uniqueness is also true. Then if something exists and is unique in mathematics, it deserves a name. So I have to give it a name. I can give it a name because that's a unique thing, yes? And I call it the nth root. That number that this theorem claims to be exist and to be unique, I give it a name and I dedicate a symbol for it. The symbol that I use, there are two ways that we can mention that number. One of them is writing 1 over n as the exponent, and the other one is using this surd sign with this n on top. Okay, so for example, if I want to make this understandable a little bit, we did it before. So for example, if I write 3 to the power of 1/2, what is the meaning of this symbol? This is referring to a unique positive real number so that when I raise it to power 2, it becomes 3. So it means exactly 3. So it means that this is not trivial. I have to, in principle, show you such a number exists in the first place and that is unique. I'm just ignoring those arguments, and I want to tell you that what is the meaning of this symbol whenever you see it. So it is referring to the unique positive real number so that if you take that number and multiply it by itself, it becomes 3. That's the meaning of this symbol. Is that understandable? And now, here, n in this case, what is n in this case? N in this case is 2, which is even. Yes? Why do you think I have emphasized when n is even, a should be non-negative? Yes?
Because if n is positive and the base is negative, then it's a non-existing number because you can't multiply it by itself to get a negative number.
Yes, because every number, even if you think about negative numbers, if you multiply them by themselves, they become positive. So the reason that I actually excluded negative numbers from this case is because if I write something like this, this is not meaningful. Meaningful means that such a number does not exist in the first place. Why? Because this is going to refer to a number so that when I multiply it by itself, it becomes -3. But any number multiplied by itself, it becomes non-negative. It cannot be negative. Yes? Any number. If you have a positive number multiplied by itself, definitely it becomes positive. And even if you have a negative number multiplied by itself, again it becomes positive. So this is immediately understandable that if I want to use the same idea here, this does not exist. Yes? So this is why when n is even, I emphasize that a has to be non-negative. It's really important, okay? Another thing, why I emphasize on being positive. Isn't it automatically trivial that number should be positive? So let me ask you again. This number refers to a number so that when you multiply it by itself, it becomes 3. If there is one such a number, definitely there is another number with the same property. Do you agree? Because if a number a multiplied by itself, it becomes 3. Do you agree that minus a multiplied by minus a becomes what? Again 3, yes? Because if a number multiplied by itself is 3, minus that number multiplied by minus that number again becomes 3. Why? Because minus a times minus a is exactly equal to a times a. And if a times a is 3, minus a times minus a is also 3. So, if I do not write this positive, then there are 2 possibilities, not 1. Okay? Is that understandable? So if I ask you, how many numbers are there? For example, let me make it with a simple example. If I write something like this, what is the answer to this problem? Yes? So the answer to this is?
4.
No. What is the answer? Equal to?
2 to the power of 2.
No, the answer to this is one number. You should tell me the number. Yes? 2. Yes, the number is 2.
No.
So this number is 2, but why not minus 2? Do you see? Why this is 2? Why the answer to this is 2? Because 2 multiplied by itself is 4. But minus 2 has the same property. Minus 2 multiplied by minus 2 is again 4. Why do we say the answer is 2? If you check it in the calculator, if you put this in the calculator 100 times, all the time, you will get 2. You will never ever get minus 2. Yes?
Because we've decided that that number means positive 2.
Yeah, exactly. So that is the convention. This symbol, mathematicians decided to give the positive one this symbol, not the negative one. Is that understandable? So this is a matter of convention. Why? Because there are 2 numbers with the same property. Why we choose to give this name, not this one, this name, that is a convention, okay? Convention between mathematicians. Is that clear? Okay, so if n is even, if a is negative, does not exist. That symbol doesn't exist, doesn't refer to any numbers. And if n is even, a is positive, there exist usually 2 of them, but this symbol by convention refers to the positive one. There is only one exception, that there is only one unique number, not 2. So can you tell me when this happens?
0.
A is 0, yes? So if I write this symbol for you, so what's the answer to this? Without any doubts, yes, there is only one number with that property that you multiply it by itself, it becomes 0. Which number is that?
0.
0. 0 times 0 is 0. Is there any other numbers here involved? No. So, in one case, there is one number, and that is 0. In other cases, there are two numbers, one positive, the other one negative of the same number, but a convention is needed. The positive one is being referred by this symbol. Is that understandable? Now let us go to the second. By the way, another way of writing this symbol is to write this. Okay, according to these symbols. But there is another convention, because a square root is actually ubiquitous in mathematics. So we have another convention. If this number is supposed to be 2, we don't write it. Yes, that's it. So instead of writing this, I would write this. You can also read it the second root of 3, but for a square, this is usually common to read it the square root of 3. Yes, not the second root of 3, but of course both of them are correct. Yeah, is that clear? Now let us go to the next one. What happens if n is odd? So if n is odd, do you think that this makes sense or not? Because here, if I ask you what is A is 5. So let me make it 6, don't get confused with evenness or oddness. So let me make it 6, and this is odd. So what is the meaning of this symbol? Can you just explain it to me? What is the meaning of this symbol? Someone else? What is the meaning of 6 to the 1/3? Yes, please?
Some number times itself 3 times is equal to 6.
6. So that's the meaning, yes? It refers to a number so that when I raise it to power 3, meaning multiplying it by itself 3 times, it becomes 6. Yes? Okay, but is it trivial such a number exists? No, it is not trivial, but you need to trust me on that. But some other parts of this we can understand, okay? Here you see, here I have emphasized A should be non-negative, but here I haven't put any restrictions on A. I have written for every real number. Okay, for example, is this strange to have this or not? Here, no. Why? Because I am asking you, give me a number so that when I multiply it by itself 3 times, it becomes -6. Yes? Might be it is not clear for you why such a number exists, but it is not like this, like the other one. Here you realize immediately that such a number does not exist. But here, there is no problem if I have a negative number here and an odd number here. Yes? So this is why here I have excluded the negative a's, but here I haven't done anything to a's. A can be any number that you like. Is that clear? Okay. But now let me ask you one question. What do you think? Do you think this number is positive or negative? The number that is supposed to be multiplied by itself 3 times and give me 6, this number refers to that number. Is it positive or negative? Yes, please?
It's positive.
It's positive because if it is negative, when I multiply it by itself 3 times, it turns out to be negative, but it is supposed to be 6, which is positive. So this number is positive. What do you think about this number? Even if you ask me what is the exact value of this, I don't know. But I know that this number is positive. You can check it with your calculator. And then what about this one? We realize that there is no problem having a negative sign here if I have odd values here. But is this number at the end a positive number or a negative number? Anyone else? Yes?
It has to be a negative number.
Yes?
Because if we had a positive number times a positive number times a positive number is still a positive number. But a negative number times itself 3 times.
Yes. Very, very nice. Very, very nice. Thank you. That's a very nice explanation. So this cannot be positive because if it is positive and I multiply it by itself 3 times, it turns out to be a positive number at the end and it cannot be equal to -6. So this number is negative. Okay? So let me this is very, very important to understand. So if I want to summarize these things, if n is even, okay, a has to be non-negative for a to the power of n to make sense. Yes? Is that understandable? If n is even, let me write also if. If n is even, a has to be non-negative for a to power 1 over n to make sense. In this case, a to the power of 1 over n is positive, is non-negative. So not only the number that I put here as an input should be non-negative, the output itself is also non-negative. This is very important in the future. So I cannot feed this with a negative number. Okay, when I feed this with a non-negative number, the output of it is again a non-negative number. But number two, if n is odd, then a to the power of 1 over n always makes sense. And a to the power of n is positive if a is positive. A to the power of 1 over n, sorry for this small writing, if a is negative. And, of course, a to the power of 1 over n is 0 if a is 0. Okay? So this is the summary that I want you to have in mind. If you have this symbol, remember, if n is even, you are not allowed to put a negative number for a. But if you follow the rule and put a positive number for a, the output of the whole combination is also positive. But if n is even, you don't need to be worried what numbers you can choose for a. You can choose whatever you like. But you need to also know that if you choose a positive number for this, the whole combination turns out to be positive. If a is negative, the whole combination turns out to be negative. And if you choose a equal to 0, the combination becomes 0. Now, is that understandable? So that is the whole thing, a picture that you should have in mind after all these discussions. Any questions? Okay, so now let us continue with some more examples. This is a little bit, I know, I would call this advanced mathematics, even though I am teaching you mathematics 1C, but might be students, I would say that even at university level, doesn't exactly know these things to describe it for you. But I just want you to understand, this way of thinking is an abstract way of thinking, and this is a little bit more advanced mathematics. If you are not comfortable with these kinds of arguments, because the way that you answer me, it seems that your level of mathematics is higher than probably I would expect for this level, so let us go higher. Okay, but these questions I will not ask in the exam, of course, but I want you to understand them, and that's up to you. If you want to understand them, remember them, or you just understand them and forget them, okay? So, now let us go here. Let me ask you some questions, deep questions, even though the answers are very simple, but I would say that these are really deep questions. For example, what do you think this will be? And why? The why is important. I'm not asking you to give me the rules. I am asking you why this is the answer that you want to provide it for me. Sergey was the first person, yes?
So,
first of all, what's the answer?
3.
3, that's correct. But why?
Because the symbol in the parentheses refers to the unique number that multiplied with itself with using 3. And if all raised to the power of 2 with using 3. And since that parenthesis there is raised to 2, that would mean that we'll get the answer 3.
I really enjoyed the way that you described it. So your understanding is really, really good and deep. Okay, so that's exactly what I expect without any extra words. Okay, so that's very, very important for me. So 3 to the power of 1 over 2 is a number by my definition, so that when I raise it to power 2, it becomes 3. What I am doing it now? I'm raising it to power 2. So what would be the answer? What would be the answer? 3. So if someone asks you why, the answer to this why is coming from the definition of this symbol itself. It's not something mysterious. Is that understandable? Now let me ask you another question. Someone else answer this. Yes, Simon?
The answer is 3.
3. Why?
Well, either you can switch places of the one.
Not yet. The switching of the places is a consequence of the definition. So the rules, this is what I want you to understand. What you are saying is this rule that we had before, yes? But this rule, we just learned it up to the level that m and n are integers. We didn't know, we still don't know, okay? Of course, I told you the previous session, all the rules will be the same. But still we don't know why, if these numbers are also fractional, we have that rule. So this is a very important thing. Because we had this rule for integers, there is no guarantee yet that we have the same rule for fractional powers, yes? So this I will not buy it. But if you can fix it, I'm ready to hear that again. Yes?
Okay, so 3 raised to 2
Yes.
is equal to 3 times 3, which is 9.
Yes?
Then we need to find the square root of 9, which is equal to 3.
Yes, but that's also based on your previous knowledge. I want you to tell me exactly the same line as Sergey just mentioned. By just using the definition, all the things that you said are completely correct. And I always will do the same thing as Simon will tell. I will never ever describe it in this way. Whenever I see this, what I do, I have an exponent, I have another exponent. What I do, I just multiply them. 2 times 1/2 is 1, and 3 to the power of 1 is 3. Okay? I will do it in that way. But here at this level, just this 15 minutes that I'm talking about, I want you to do everything from scratch. Yes? Yes?
Because 3 in this situation raised to 2 is already the unique number. And if we raise it to 2, it becomes 9.
Yes?
Which then should be raised to 1/2, which basically also is the unique number. So, yeah.
No. The sentence should be in mathematics, you should be very, very precise. Yes? You can have another chance to repeat it again, but that was not the statement that I will buy it. I told you that this is deeper mathematics. Don't worry if you don't understand these things. But I don't believe that you cannot understand these things. Okay? So anyone else? So let me ask you again. If I so you see this trick, how many times I am using? Learn this trick. If I ask you what is the box to the power of 1 over 2, I am more or less 90% sure that most of you can tell me what is the meaning of this. Is there any volunteer to tell me what's the meaning of this symbol? Something in the box to the power of 1/2. Some of you should be able to tell it to me. What's the meaning of this? Yes?
It's the unique positive. I don't know if it's a number at this point.
Yes, exactly. Something.
The unique positive something, which when multiplied by itself becomes that box.
That box. Is it clear for everyone? Yes. So why do you hesitate to tell it to me? You can make me happy, okay? By telling that, I would be happy that you're learning, so I will be excited, okay? Otherwise, that would be a waste of my breath. Yes? Okay. So do you see how many times I'm using this trick? But now, this is playing the role of your box. So again, can someone tell it to me? It is something, it's a number of course. When I multiply it by itself, it becomes the box. It is a number, it is the unique positive number, so that when I multiply it by itself, it becomes 3 to the power of 2. What is that number?
No.
No. What is the unique number so that when I multiply it by itself, it becomes 3 to the power of 2?
3.
3. So that's why this is 3. Is that understandable? So this is very, very important. So I haven't used that. Of course, in the future, I will never solve this problem like that. I have a rule in my mind. If I have 2 exponents, I multiply them. So what is the answer to this? If I want to solve this, what is the answer? I would multiply these 2. Even in my head, what is the answer here? It's 1. And what is 3 to the power of 1 is 3. And again, if I want to solve this, I multiply these 2. But here we don't know yet that rule works. Then it becomes 3 to the power of 1, and that is 3. Yes? So the reason that this is 3 and this is also 3 is because of the definition. This tells me that I want to give me a number so that when I multiply it by itself, it becomes 3 to the power of 2. So what that question is, question mark is 3, yes? So this is the reason that this is 3. Understandable? Yes or no? Okay. So now we can more or less have the same situation. I have a to the power of 1 over n to the power of n is equal to a to the power of n to the power of 1 over n is equal to a. Yes? So we learned this. It doesn't matter if I have this scenario or if this scenario, it becomes a. Of course, I have to be very careful sometimes because sometimes this symbol doesn't make sense. So I am just, when I write this formula, I am telling you whenever it makes sense. So for example, if a is negative and n is even, for example, if I write this, this is what I ask you to understand. So let me write it in this form. What is the answer to this? Anyone else? What's the answer to this? Yes?
-2.
So you wrote -2. How many of you agree with that? Yes? Do you agree? Yes, 2. Do you agree? Why?
Because if you multiply to a negative exponent by itself, it becomes positive.
Yes. So if I call this box, yes, this is box to power 4 is -2. But is it possible?
No.
Because even if the box is negative, when I multiply it by itself, it becomes what? Positive. So the answer is definitely wrong. So this is why I am telling you, deeper understanding is needed. If you blindly use the formulas, you get the wrong answer. Is that clear? So if I give you this in the exam, and if you write -2, you see this is not a complicated mathematics problem. -2, 4, and very familiar things for us. We have it, and the still answer is wrong. The reason that I cooked up this, because I have experienced that all the students make these mistakes. I want to prevent that, if you want to have a deeper understanding, okay? So, first of all, I want to convince you this is wrong. Because if this is a number, when I raise it to power 4, it is not possible to become a negative number. So this is clear that -2 is negative, is wrong. Why this strange thing happens in the first place? Because I am not following the exact rules in mathematics. Why is that, do you think? Yes, Rasmus?
Because n is even in this case, and if n is even, then a cannot be
Negative.
less than.
So it means that this is nonsense. This box is not a number. Yes, these rules are working if they are defined numbers. This box, is it a number? Is it a real number? No. So when this is not a real number and it doesn't make sense, so I can only raise numbers to power 4. It is like this. If I ask you 5 over 0 to power 7, what is the answer to this? Can I write this is equal to 5 to the power of 7, 0 to the power of 7? Because you know that we had this rule, but you shouldn't use the rules blindly. I had this rule, but this rule has one exception. What was that exception? This rule always works except
Denominator cannot be 0.
So b is not 0. So be careful. Whenever you learn a formula, you need to know where this formula is indeed applicable. You are not allowed to use it blindly, okay? And it is clear that this does not make sense, because when I raise something to power 7, that something should be a number. Raising to powers is dedicated for numbers, but 5 over 0 is not a number in the first place. So I'm not allowed to. Exactly the same scenario here. Is that understandable? Yes or no? But let me ask you a little bit tricky. Don't spoil this question, okay? I will come to you, okay? What do you think would be this question? Yes, Afsha?
I think the answer to that one is -2.
So you said it's -2.
Yes.
How many of you agree with that? How many of you agree with that? You can also correct yourself if you want to. Let us go back to this remark. Whenever I write something on the board, be careful. It's really important. This is coming from my 30 years of teaching experience, okay? So you see, if n is even, a has to be non-negative. And then, after we respected that, this combination should be non-negative. And now, this, if you call this a box to the power of 1 over 4, 4 is even, so the output should be non-negative, but you provided me with a negative number. So respect that remark there. Can you correct it yourself?
Yes, it's 2.
It's 2, but how many of you agree with 2 now? So Abdirrahman, can you explain why this is 2? First of all, tell me, is this meaningful or meaningless in this case? It was meaningless in that case. Is it meaningful in this case?
I don't know.
Okay, so Sergey, you are nodding. So is that meaningful or not?
I think that's meaningful.
Can you explain?
Because -2 to the power of 4 would be positive 16.
16, that's enough. So thank you very much. So positive 16 is a positive number. So and this makes sense for positive numbers, yes? So even though I am playing with negative in front of your eyes, you shouldn't be fooled, yes? The whole combination is positive or negative. Even though you see a negative sign here, that negative sign is not relevant here. The whole package shouldn't be negative. Is the whole package, if the answer to this is negative or positive? The answer to whole package is positive, because if you multiply -2 4 times, it becomes how much? 16. So now, so this answer is correct. Why? Because this is the unique real positive number. When I multiply it by itself 4 times, it becomes 16, which is exactly this another name for this number. So you see, this was wrong, and then suddenly this becomes correct, and then this minus sign is gone. So this is what I want you to have a deeper understanding. If you do not respect these things, most of the time you can solve easy problems. When it comes to some points that you really need to understand, then you cannot solve them. Do you understand? So whenever you want to talk about these things, you have to understand the domain of applicability of the formulas, not just blindly memorize them. Yes? Is that understandable? So this is completely nonsense. We cannot talk about this. We cannot fix this, because this is not possible. But here the answer is not -2. The answer is +2. Okay, let me ask you another question. What is your opinion about this? What is the number? Yes?
It doesn't exist.
It doesn't exist, thank you. Why? Because even though 2 to the power of 4 is positive, but this minus sign is not under the influence of this power. So if I ask you what is the answer to this package, it is -16. And because this is even and this is -16, it is not defined at all. So you really have to have a good understanding, otherwise it is useless. If you just memorize the formulas without understanding how to use them, it's not that important. Now your question, please. And louder, please.
If we get this sort of question on an exam, are we supposed to just write undefined as an answer?
Yes. Yes, but I will stick to the level exactly of the questions in the book. I haven't checked the questions in the book. Have they talked about these things? If they are not, so I will not give them in the exam. But I really want you to understand them even if they are not in the exam. I want you to learn not to study for the exam. I want you to learn to study for the subject you are studying itself, if you like it. Yes? So that's what I mean. In the exam, I will not probably make a lot of trouble for you. I just want you, because I know that the grades are also important for your future. If you don't have good grades, you cannot enter the university. And then if I raise the level of questions so high, there is no, unfortunately, the Swedish system is not very fair. Because if you just go to a very low level school, I don't know, it's good to say them in the camera, but if you just go to a low level school and get a grade A, then you will win the competition for the entrance in the university, which is not fair. So for example, you come here, the questions are harder, you get a B, but your B is probably worth more than the A of the other school. But in the exam, in the entrance exam, you lose the competition because of the grades. So I'm completely aware of this bad situation. So I will keep this standard exactly according to the book, but it doesn't necessarily mean do not teach you the real mathematics. So you can learn the real mathematics. By the way, if you learn the real mathematics, you can also solve the exam questions. But it is possible to get an A in the exam without good understanding of the subject. So what I'm saying is that if your understanding is perfect, definitely you will have a grade A. But you might have a grade A without having perfect understanding. Okay? So I am not that kind of teacher to teach you how to get an A without understanding. And that is actually cheating, and I really don't believe in that. Because the whole point of studying lessons in mathematics or any part is that you have to be better than your teachers. If that's not the case, then we cannot progress. Yes, I have spent a lot of time learning these things. The role of a teacher, from my opinion, I don't remember the American physicist who said that. He said that the role, more or less something like this, the role of a teacher is to teach you a subject in 1 year, the same subject took him or her 2 years to learn. Yes? So because I was new, I struggled, I learned something in 2 years, I need to tell you this package in 1 year so that you have 1 year left to practice, to do research and push the science forward. Otherwise, if you just want to repeat what I know, what's the point? At the best point, you become me. What's the point of that? You have to be better than me, and the next generation have to be better than you, you know? So that's the idea. So this kind of thing doesn't come by just memorizing and getting A's or things like that. It comes by deep understanding. Yes? And you need to have also a passion for your subject. It shouldn't be mathematics, of course. You might be very interested in literature, biology, or whatever, but you really need to have a passion. Sometimes you prefer to work on your subject than going to the cinema, to the park, or whatever. Yeah, I want you to make it a little bit enjoyable, but the people who like mathematics, so at least then if you like it, you can spend at least 1 hour or 2 hours a day learning mathematics, and it will pay at the end. Okay. I forgot your question. Did I answer your question? Yes. Okay. So now I think that is enough. But the good news is that you can be a little bit relieved. So you can use whatever rule that you have learned for just other powers for a fractional powers. Yes? So don't worry about that. For example, if I ask you to calculate this, to write something for this, if you want to, what can you write? You can write 2 and you can add the exponents. Of course, proving this is a little bit harder. You can also think about it yourself. Why this relation should be true. It's not that trivial. Why it's not trivial? Because this rule was we showed this rule for integer powers, not fractional powers. But why this rule also works for fractional powers is not trivial. If you want, you can work a little bit on that. Now, if I want to add them, can you add these two fractions in your head? 1/3 plus 1/2. Yes?
5 over 6.
5/6. Yes? So it's 5/6. By the way, now the question, if you are curious, if you are picky, you realize that I have to define this symbol for you. Because so far what I have defined for you are exponents whose numerator is exactly 1. But what happens with this? This needs to be addressed. What do I mean by this number? This number is defined to be, semicolon equals to means defined to be 2 to the power of 1/6 to the power of 5. Yes? So that is the definition of that. 2 to the power of 1/6 refers to the number, so that when I multiply it by itself 6 times, it becomes 2. Now I am taking that number and multiplying it 5 times. Yes? So that is the idea behind it. But now every rule that you have already learned is true for these powers, for these exponents, and even for these kinds of exponents. We talked a little bit about this before, that what happens that I have an irrational exponent. I told you that you need to have an infinite sequence, and that infinite sequence accumulates around one number. That number is called this. But forget about these more advanced topics. Okay, so now I want to just start doing some problems, exercises that you need to know for the exam. Okay? So, for example, can you answer me this? What is the 5th root of 32? So this, now we have to practice to be quick. After deeper understanding, we have to be fast in answering these questions. So, let me tell you, while looking at this number, what is the question that you need to ask yourself? You need to ask yourself about a number so that, what? So that when I raise it to power 5, it becomes?
32.
No, it becomes? 32. So what is the answer?
2.
The answer is 2. Okay, is that understandable for everyone? Yes or no? Okay, when I ask you this one, again, let us repeat this. Let us read it first. How we read it? The 4th root of 16. Okay, so it is referring to a unique positive real number, so that when I raise it to power 4, it becomes 16. What is that number? Yes? 2 again. Why we do not accept -2 even though -2 to power 4 is 16? Because of the convention that we have to choose the positive. Yes? Exactly. And by the way, don't underestimate these learning that you have learned. I have seen many students, even higher level students, university, they write plus or -2. This is wrong. Yes? Square root of 4, the 2nd root of 2 refers to the unique positive real number, so that when you raise it to power 2, it becomes 4. So you can test it. You can punch this in your calculator from today until the end of this year. You will never ever get -2 even once. So -2 is not the answer, even though -2 to power 2 also becomes 4. Be careful about that one. They confuse this with something else. Let me just describe it for you here. If I ask you to solve this, if I ask you find possible values for x, so that x squared is 4, then how many answers are there? 2. -2 and +2. It doesn't mean that the square root of 4 is plus and minus. Okay? If I want to write it clearly, I have to write it in this way. This plus and minus is coming from here, not because this is plus and minus. This is always 2. Plus and minus is coming from... I will talk about these equations later. Okay? So what do you think about this? Okay, first of all, tell me, does this make sense or not? Does it make sense? Yes, even though it is negative here, I don't have any problems because this number is odd. So, no problem. But can I imagine what is the meaning of this number, this symbol?
The entire symbol.
Yes? Just describe it and then give me the answer. What is this symbol referring to?
The third root of minus 64.
No, refers to the number so that
Okay,
when...
yeah, the number, so when multiplied by itself 3 times it becomes negative 64.
64. Now, this is exactly the same thing that you need to enter. What is the answer? Do you have it in your memory? It's minus 4. Agree? So, minus 4 times minus 4 times minus 4 is minus 64. Is that clear? Okay. But, what happens, for example, if I couldn't calculate it in my head? For example, this number was small, so you might be able to guess. But if I couldn't guess, what can I do? For example, you can write this. Another name for this is writing it as a power. Yes? Agree? And then what you do, if this number is big, I told you how to factorize them. Yes? So if you don't have, this number is so big that you cannot calculate it in your head, but you need to know how to factorize a number to prime numbers. Yes? So what is that? I put a 2 here, it becomes 32. I put a 2 here, divide. 16, 2, 8, 2, 4, 2, 2, and then finally 2, 1. Always you end up with 1. So what I can do, I can write minus 64 to the power of 1 over 3. So then instead of minus 64, I can write 2 to the power of 6, and I have a negative sign here. Because this is odd, I can pull the minus sign out. I will also explain it to you if you don't understand that. But then I told you that whatever rule we had before, we also can use it here. So what's the answer? This would be 2 to the power of 6 times 1 over 3. 6 times 1 over 3 is what? 2. And then this becomes what? 4. And I have a negative sign here. It's minus 4. So is that understandable? If the number is big and you cannot calculate it like this, so what you have to do is to use the factorization method. So when you use the factorization method, you can use the rules of exponents. So is that understandable? Yes or no? So let me just mention this one. Remember that if I have minus a to the power of n, n is even, n is odd, I can pull a minus sign out and write this. These two are the same. So it's very important to write it somewhere in your notebook. So if I have a negative sign and this n is odd, I don't need a pair of brackets. I can just write it as that. This I want you to convince yourself of this. It is not hard. You already answered that actually there. But this is the general rule. So is this calculation clear for everyone? If you can guess, yes, guess it. But if you cannot guess if the number is, because we cannot rely on our ability to guess, if the number is so big, no one can guess. We have to have a systematic way to calculate. So, and what is the systematic way to calculate? Is to write this as a product of prime numbers. So, I want to wait a little bit for you. Just please review these equalities and calculations. If there is one part you don't understand, ask me now. Because this is something that you get in the exam. And you have to be able to write it in this way. Okay? Is that understandable for everyone?
Do we have to write
No. If you want, you can jump from here to here. I will not ask how did you understand that. But, yes, but in general, if you don't know yourself, you have to do something like this. Yes. Is that clear? Yes?
It repeats why you can remove the brackets.
This is, okay, if you want, I can explain that to you. So, if n is odd, you can remove the pair of brackets. If n is even, that is meaningless in the first place, yes? So, for example, let us consider this. Minus 3 to the power of 1 over 5. And let me consider minus 3 to the power of 1 over 5. So, minus 3 to the power of 1 over 5 and minus 3 to the power of 1 over 5. So what is the relation between these two? So let me ask you something. Minus 3 to the power of 1 over 5 is a number so that when I multiply it by itself 5 times, it becomes minus 3. Yes? So what is this number? This is a number so that when I multiply it by itself 5 times, it becomes positive 3. Okay, so what is the relation between these two numbers? So let me tell you. For example, assume that this is x. This means that if I multiply x by itself how many times? 1, 2, 3, 4, 5 times, it becomes minus 3. Yes? And now let me call this one y. What is the meaning? It means that if I multiply y by itself, how many times? 5 times, it becomes positive 3. Agree? But x multiplied by itself 5 times is x to the power of 5 is minus 3. And then multiplying this by 5, it becomes this. Now, by comparing these two, can you guess what is the relation between x and y? Because you see, x and y are numbers. One of them to power 5 is minus 3. One of them to power 5 is positive 3. Yes? Do you see that these two numbers are opposite of each other?
Yes.
Even though if you ask me what is the value of x, I don't know. But I know whatever x is and whatever y is, they are opposite of each other. Because one of them, after being multiplied 5 times, give me minus 3. The other one, after being multiplied 5 times, give me the same number just with a different sign. So they have to differ only by one single negative sign. So the conclusion is this, that x is equal to minus y. Do you buy this conclusion? From comparison of these two things, I can conclude that x is equal to minus y. Is that understandable?
Yes.
Okay, now what was x? X was this. What was y? Y was this. And then there is a minus sign here. And now this is the reason that I can remove the pair of brackets. Exactly for the same thing, you can just talk generally. If n is odd, it's very, very important. Then it doesn't matter if you put a pair of brackets or you don't. Did you understand Did you understand why? So this is the reason. So it's very, very important. Write it as a remark. So you need to somehow send them in your memory, because every time, of course, the first few times, try to understand it, and after understanding it, just try to do it automatically, because it would be very, very slow if you want to describe every one single step that you would take. Is that clear? That was the question. Any other questions in this calculation? Okay. If I ask you this, what is your answer? What is the answer to this? Yes?
It's undefined.
Undefined. Does not exist. Undefined. Why is that? Because this is not written, it means it is even. That number is 2. So this is the second root of minus 6. Remember, I am telling you it is not defined, but when you reach to Math 4, we learn something about complex numbers. So what we are working right now is the set of real numbers. And then exactly because of these problems, mathematicians extended the set of real numbers to a bigger set, which is called the complex numbers, and it contains these odd numbers. Some of them is called imaginary numbers. So a very nice word for this that is still used in complex numbers is imaginary numbers. Yes?
Are the examples that you're showing us right now like in the book?
Yeah, they are similar in the book. These examples. Yes. So for example, this is something it's also in the book. So you need to know that if that is even, there's a negative number, it's not different. Okay, now there are some rules that we want to discover. By the way, what is the answer to this? Can you tell me? What is the answer to this? Yes, Tim? It's 5. Everyone understand that? Yes. What is the answer to this? And what is the answer to this? What is the middle one? Yes, Ali?
-5.
So you answered -5. How many of you agree? 5. Yes, the answer is 5 again. Not -5. You see, don't fall in this trap. Because it is asking you, give me the unique positive number so that when I multiply it 4 times, it becomes -5 to the power of 4. Is that clear? That number is 5. Because 5 to the power of 4 is exactly as -5 to the power of 4. But what about this one? Everyone, just what is this?
-5.
What is this?
-5.
No, you don't listen. What is this? Undefined. Don't think these are the questions in the book, by the way. You need to understand them. Okay? So, why this is undefined? Because if I ask you, this number is positive or negative, answer that. Positive. Is this number positive or negative? Positive. Is this number positive or negative? Negative. And if it is negative and this is even, it is not allowed. So it is undefined. But these are defined because the number below is positive. So I don't know, write them somewhere so that you don't get confused. Of course, there is nothing serious about 4. Let me make it this. Let us just play this game again. Let me make it the third root of 5 to the power of 3, the third root of -5 to the power of 3, the third root of -5 to the power of 3. Okay, now if you are a volunteer, please let me know. What's the first one? Anyone else? Yes?
5.
It's 5. How many of you agree with that? How many of you disagree with that? Okay, so what about this one? Another person. Yes, what's your name?
Leo.
Leo, so?
5.
It's 5. How many of you agree with that? How many of you agree with that this is 5? Sergey, you agree? Anyone else? How many of you disagree? Okay, Angelina, can you describe what is the correct answer?
It's 5.
No, so you agree or disagree?
No, it's -5.
It's -5. Why?
Because like 5 times itself, 3 times is. Oh well, yeah.
No, don't get confused. You answered correctly. You said that the answer is -5,
Yeah,
and the answer is indeed -5.
Yeah, because -5 times itself.
3 times is -5 to power 3. Exactly. So if you doubt that this is -5, ask me questions. Everyone understand that?
Yes.
What about the next one? Yes, Leo?
Undefined.
How many of you agree? You?
No.
Do you agree?
No.
So what's the answer?
-5.
Again, -5, thank you. So you see, this you need to learn at the end. So the people who actually really understand that, it's important. You see, these are not hard questions at all. I'm just giving you very simple questions and I'm asking you. So this is 5 -5 -5, but this is 5 undefined. So write it somewhere in your notebook. You have to go back and convince yourself that this is true. Yes, please. What's your name?
Abdurrahman.
Yes, Abdurrahman. Okay, you
Why
have to.
the last one -5?
So why is that? Because this means, let me just do it for you in this way. Do you agree with this one? The third -5 to the power of 3. Do you think I can write it in this form? Do you agree with that or not? Yes, because this is another way of writing this. But I just told you here, you see, if I have a negative sign in pair of brackets, and if n is odd, I am allowed to remove the pair of brackets. Yes? So you see, here I have a pair of brackets, I have a negative sign, and this number is odd, so I am allowed to remove the pair of brackets Actually, I put minus sign out and this one. This was not a very good idea. I can pull the minus sign out. So I pulled the minus sign out. But if I ask you answer this part is 5, and then I have a negative sign here, so it becomes negative 5. Yes? So let me write this one here for you as well. So this is also, you can write it exactly close to where you write this. If I have the nth root of minus a, n is odd, this is extremely important. You can pull the minus sign out. They are the same thing, but I think you need to know both of them. So you have to be very quick in these kinds of calculations. If you have a negative sign under this third sign, and this n is odd, you are allowed to pull this negative sign out. But if this is even and you have a real negative sign, this you are not allowed. This is not defined if the number is negative. Is that clear? Yes or no? Now, Angelina, do you understand what's going on exactly now? Yes, okay. So your answer was completely correct, and thank you. Okay, so now we want to try to invent some kind of rules. If I ask you, what can I write for this? What can I write in front of this? Shh, do not talk in the lesson, okay? So that's nth root of a times the nth root of b. Yes?
Nth root of a times b?
Yes. So this is a very, very nice formula. I don't know if you get it in the formula sheet or not, but you have to know it. Oops. This is b. Yes, we want to convince ourselves for this one. It's a very important formula. If I want to multiply two nth roots with the same n, I can write the same nth root and multiply the ones below them. Yes? But of course, if n is even, I have to respect that a and b shouldn't be negative. So whenever I write a formula, I implicitly think in this way, that if n is even, the numbers below the nth root are non-negative. Yes? And if they are odd, I do not have any limitations. But why this is true? I told you that whatever you know about the powers also works here. Yes? Do you want to say something? Yes?
Because the nth root of a and nth root of b is the same thing as writing a to the power of 1 divided by n.
Very good. Just wait. So I start from the left hand side. Thank you. So you are saying that this is another symbol for this.
Yeah.
Yes? And this is another symbol for this. And then the rules of powers, I told you that we will use them from now on. So what is this one? I have the same power with different bases. So what was the rule? Do you remember? We had this before for n. But now I told you that the same rule will also apply here. So what I can do, I can write a dot b to the power of 1 over n. But what is another way of writing this is to write the nth root of a dot b. And that is exactly the right hand side. Yes? So I started from the left hand side. I calculated everything, I reached to the right hand side. Of course, there should be a limitation. You need to be careful. Do you think this makes sense? Fourth root of minus 2 multiplied by fourth root of 5. Can I use that rule? Let me write it in this way. Do you think this is correct? Yes or no? No, because just blindly using the formula is useless. This formula works if they are numbers. If they are not numbers, I cannot multiply them in the first place. So if this is not a number, because this is negative, so how can I multiply two things that are not numbers? So this is not valid. Be careful. But so whenever you want to use this formula, you have to be very careful about that. So this is also a very important rule. But I have seen a lot of mistakes. Some students write like this. For example, I have seen many times, even university students sometimes are tempted to write this. Do you think this is also correct? Be careful, this is not correct. Why? So do you think that this is correct? We talked about this before. A squared plus b squared. Can I write it as a plus b to power 2? No. I cannot do that. Yes? A squared plus b squared is not equal to this. So this only works if this is a product or division, not addition or subtraction. So be careful, this formula is not correct. I cannot write square root of, for example, this formula is not correct. This formula is not correct. Be careful, not use them. You should be careful not to use them. But this formula is correct. What do you think? Is it correct also for division? It was correct for multiplication. I warned you that they are not valid for addition and subtraction. You can find the example that doesn't work. But do you think this formula also works for division?
Yes.
So, for example, my question is this. The nth root of A divided by the nth root of B, can I write it as the nth root of A divided by B? Again, the answer is yes. Why? Because if I start from the left-hand side is another name for this is a to the power of 1 over n. Another name for this is b to the power of 1 over n. But I told you that every rule in the powers will work here. So I will write a over b and I put 1 over n here. Now if I ask you what is another symbol for this? Another symbol is exactly this. And that is exactly equal to the right-hand side. But of course here, b shouldn't be equal to 0. And if n is even, I am not allowed to choose negative numbers. Yes? So I don't write them because it takes a lot of time, but I'm just talking about them orally. So these are the very important formulas. Write them down. I am not sure it is given in the formula sheet or not. But even if it is not, you have to be able to use them in the exercises and the problems. Yes? Now, I just give you one trick and then stop this today's lesson. It was a long lesson, and I think finalize everything on Friday. So next week we go to the second, actually, part in the book, which is algebra, and it would be very important. So, if I ask you, let me ask about square roots first. If I ask you what is the square root of 16, you can answer me. What is the answer? It's 4. But if I ask you what is a square root of, for example, 48, this is not an exact number. Okay? So square root of 48 is somewhere between what? 6 and 7. Yes, it is bigger than 6 because 6 times 6 is 36. It is smaller than 7 because 7 times 7 is 49. But what exactly we don't know. The problem is not as before. Either you should leave it like this. If I ask you for exact values, if I ask for exact values and you put it in the calculator and write decimal points, you will lose some points. You need to respect the word exact. The word exact is this one. You cannot write it better. But you can write it more efficiently. How? This I want to teach you now. Instead of square root of 48, can I write a square root of 3 times 16? Because 3 times 16 is 48. Okay? According to this rule, from this direction, I can separate this as a square root of 3 multiplied by square root of 16. Yes? It's extremely important to know this calculation. These are exercises. But can I know this exactly? This is how much? 4. 4 multiplied by square root of 3. A square root of 3, I don't know it exactly. So I have to keep it in this 4. So the answer would be 4 square root of 3. There is a multiplication here. I don't write multiplication. So when I ask you to simplify this third, what I mean is that you write this for me. So this is better than this one for us, because 4 is very familiar for us, and a square root of 3 is more tangible than a square root of 48. So square root of 48 is 4 times the square root of 3. So this trick you have to learn to simplify these things. For example, let me give you another example. If I give you the third root of 54, can you simplify it for me? Of course, is there any exact number whose third power is 54? No. The third power of 3 is 27. The third power of 4 suddenly becomes 64. So this number is somewhere between 3 and 4. So this is not my point. My point is to simplify this. So what is that? How can you simplify this?
You can write 54 as 3 times 18.
No?
Squared.
Oh, 18 doesn't help. Yes, you are right, but why 18 is good? So you are right. What you said is not wrong, but it is not useful. You said that let us multiply it like this. That is good. Then you can write like this, and then you can write like this. But none of them can be simplified anymore. So what you have written is completely true, but it is not that useful. So, yes?
Here it is, 2 times 27.
27. So, 3, I will teach you how you understand this later, okay? 27. 2 times 27 is 54, but now can I write this? I can write it like that. But now if I ask you, do you know exact value for this? The answer is yes. The exact value of this is 3. And then I write it as 3 times the third root of 2. So another way of writing this is to write it as 3 times third root of 2. Okay? I will stop here because I understand that you are tired. You are not used to long lectures, but you have to get used to that. Okay? I will complete this lesson, which is very important, on Friday, and then after that we go to the next lesson. Thank you.